So there's two types of patterns that you might be interested in looking for. Like you might ask yourself, what is the same?
Yeah.
And then you might ask yourself, well, what is different? And that helps you to figure out how to eliminate possible answers.
Okay.
So we want to do something to be able to eliminate some of the answers, and that's kind of the key thing here. So what we're going to do next is look at just the answers in the problem, just the answers and not the actual question. We want to get good at this skill, and test taking is about working on your skills, kind of like working on your your forehand, your backhand, your serve when you're playing sports.
Yeah.
So, oops, that's not what I wanted. Just wanted the answers. Okay. Now we might have looked at this problem. I'm just pulling this from my notes from one of the classes I taught. The mean of each data set is 2. The mean of each data set is 4. The mean of data set A is less than the mean of data set B. The mean of data set A is greater than the mean of data set B. Can you tell me anything that's similar or different about any of these answers? Like, what do you see that's same or different when you're looking at them?
A and B is like it equals to a number, and then C and D it's like greater than or less than.
Yes. It's kind of an obvious thing. It's like, well, yeah, but the more you do this, the more you will be able to quickly figure out, I either need to determine the mean, or I need to know whether the mean of one is bigger than another.
Yeah.
All right. So let's look at another question here. Or actually another set of multiple choice answers. And again, they're sometimes really long to read. So you have to almost read them like as R increases, as R increases, as R increases, if R equals. So that tells you the first 3 are kind of the same. And it goes on to say here, as R increases at a constant rate, as R increases at a constant rate, as R increases at a constant rate. Then it goes on in A and B to say V increases more rapidly, V increases more rapidly, and so on. So A and B are really similar. Can you tell me the difference between A and B? What is the main difference between A and B?
Compounded annually, and then the other one's compounded daily.
Yes. Okay. So typically, like if you wanted like a general guideline, right? We know that it doesn't work for all questions all the time, but the two answers that are kind of most similar with just a word flip typically are the ones that end up being the answer, but not always. All right. So let's take a look at another multiple choice answer. All right, so this time I want you to look through this and just tell me some things you see that are the same or different. Tell me what you see.
B and C are similar.
What's the difference between B and C?
Greater than, and then one is less than.
Right, so the quicker you can identify those types of differences, the more often that you'll be able to answer the question. So now I'm going to put the whole question in front of you. And so one of the reasons you read the answers is that it helps you to figure out, well, what am I even looking for? Like if the bus had the most riders on Tuesday, then something should indicate that. Or if Tuesday through Sunday, it was getting greater or getting smaller, I should be able to see that. So let me put the entire question in front of you now and see if you can answer it.
Okay.
All right, there you go. Put that in front of you.
Is it B?
Okay, sorry, I was muted there. So B
Oh.
says that it gets greater, starting on Tuesday through Sunday. Is it greater going from Tuesday to Wednesday?
Oh no.
No, in fact, it's getting smaller, so it might be C.
Would it be D?
It is. So there's always an exception, right? There's always a problem where, we talked about, well, it's often the ones that are very different. Sometimes it's just the one that is kind of a one-off. But it does help you to establish, well, what to do. Okay. Now, I'm going to throw another problem at you here. Yes, we're going to snip in just the answers though first. So you might also think this only applies to written answers or story problems, but in fact, it applies to everything. Okay. What do you notice about the first two answers?
It like equals to something.
Yeah,
It's like a number.
there's some sort of numbers or numerical values.
Yeah.
What about the second two? What do you notice about those?
It's just words.
They're just words. Now, these words have meaning. Now,
Yeah.
I haven't framed this question with you yet, but it refers to the fact that a system of equations, there's three possibilities. There's no solution, one solution, or there's infinite solutions. And that's what these answers say. They say, okay, the solution is 0 or 10.5, or it has infinitely many solutions, or it has no solutions. So sometimes there's a lot that you can extract from it, but you have to put it in context here. Let me give you the problem. And I think we talked about, you can try the answers. Absolutely can try the answers. You'll see here that if you go down the path of trying the answers, if it's not 0, then you got to try 10.5, and that might not be the best strategy. So you may want to direct solve this. You may want to just manipulate that equation there and see if you can get X by itself.
Okay. Is it 10.5?
Did you try it and did it work, or is that what you solved it to be?
That's what I solved it to be.
Okay, let's take a look here. So 4x minus 1/2 x minus 7. I'm going to distribute this 7 over here, so it becomes 7/2 x minus 49, like that. Now on the left here, you've got to be fast at dealing with fractions. So you can either combine them or say, you know what, I want to multiply everything by 2. What did you do? Did you combine the 4x and the minus 1/2 x, or did you multiply everything by 2 or something else?
I didn't combine it by 2. I did the other thing.
You multiplied, I'm sorry, which way did you do it?
I didn't do the 2.
You did not. Okay, so let's go ahead and just combine it. So it ends up being 8 over 2x minus 1/2 x, which is 7 over 2x minus 7 equals 7 over 2x minus 49. Now, the thing that's not good here is that if you kind of look at these one-on-one, one side versus the other, the left side has a slope of 7/2, if you can imagine this being an equation, y equals, and then, same thing over here, y equals. They both have the same slope. Okay, so that's potentially bad because lines that have the same slope are either parallel or they're the same line.
Yeah.
Okay, now their b value is different, -7 versus -49. So when you have the same slope but different b values, that means they start at two different places. So not to scale, one starts at -7, one starts at -49, but they have the same slope.
Okay.
So these never intersect.
Oh, okay.
Now I know 10.5 is there because there's a way to manipulate the equation to get that. But hopefully it's clear now that you can start looking at the equations of lines and things like that to do it.
Yeah.
All right. I always forget to start with this question. This is actually the best question to start with. When you look at these four equations of a line, tell me something that's the same, tell me something that's different about them.
The 2x and the 3 and the other one has 3x and the 2.
Okay, tell me a little more. What does the 2 and the 3 refer to in front of the x?
Is that like your coefficient?
It is, but we just talked about it here. The number in front of x is the
Slope.
slope, yes. So these two have the same slope. And these two have the same slope. And then if I copy them, I know you don't have the ability to do this, but if I were to copy them and say, all right, well, what do they all have that's different? What is this right here? What's the second number?
Is that like the left or right thing?
This is the y-intercept or the b value.
Yeah.
That's where it crosses the y-axis.
Yeah.
So if you notice something that's different in every single one, that helps you to find the answer. Okay, I'm going to throw the whole question in front of you. This is the entire question. Where does this graph cross the y-axis?
-2.
There's your answer.
Okay.
Now, I'm sure you could have done that without doing it this way, but the idea is scan the answers. You read the call to action, then you scan the answers, and hopefully you find something that helps you to determine the answer, or you know what to go and look for, which is even better.
Yeah.
All right, so let me do a couple more here.
Okay.
All right, so here's another group of answers. Tell me what you see that's the same, that's different.
One has 24x and a 3.
Okay.
And they and 3 of them have x squared and one just has x.
Okay, I agree. That's good. Anything else you notice?
One has 2 variables and the rest don't.
Okay, so kind of like related to that is the first answer has one term,
Yeah.
the second answer has two terms, the third answer has three terms.
Yeah, that's what I meant.
Okay. All right, now I'll put the whole problem in front of you and see if there's something you can do to answer it without like what you don't want to do is foil this. You don't want to do that because that takes too much time. Is there a way to leverage the fact that there's a difference in them to find the answer?
Well, you know it's not gonna be A.
Okay, I agree. How do you know it's not A? I think there's something there though. What were you thinking about when you said that?
Because it's gonna have more than one variable because there's a 3, and then
Exactly.
you would get like an x squared in it too. So it'd probably
Okay.
be C because there's like 3.
Right. Yes. And it is C. It is C. I mean, and it, for exactly the reason you just said. So notice you don't have to actually do anything. You just have to notice stuff about this.
Yeah.
And like all the strategies I'm going to talk to you about, there's no like, it's not one where it's going to work every time, but it might be a problem where you have like no idea what to do and you remember, oh yeah, Matthew and I were doing that lesson on May 25th, and he talked about this idea of looking at the answers, right? So it's a pretty interesting approach. And truthfully, this is what I do when I work with students is I often don't actually work out the problem. I kind of look to see what the answers are to do that. Now, this
Yeah.
approach also works with charts.
Okay.
So let me put a chart in front of you. We might have looked at this, but who knows? It's been a while. When you see a chart like this, you can ask yourself the same question: what's the same and what's different?
Um, like the first set of like data is the same,
Okay,
and then one just has like extra.
right.
Like,
So I would like for you to look at the answers first and try to answer it that way. Just try to look at the answers. Don't even read the problem. Just look at the answers and then try to see if you can answer without much more than that.
um, B.
The mean of data set A is greater than mean of data set B. Yes. And notice you did not have to calculate it. You just had to look at the graph
Yeah.
and see that it was different. All right, good job. Looking for a certain question with another chart in it. I wonder if it's in class 3. Look at one more class. Come
Okay.
on. Okay, so I'm not finding it, which isn't surprising. The course materials need a refresh, but let's keep going here. Do a few more of these, and then we'll talk about it. So let me put another graph in front of you. And I know like on the test you would have the words there, but what you could do is cover up the words with your hand, or if you have a piece of paper there or something. Like sometimes it's good to just focus. Like what is the same, what is different about these?
One starts at 1 and one starts at 2.
Good. Okay, I like that. Is there anything else you notice or see here that you could just
One has like a steeper slope, and
okay?
2 has like a wider slope.
Okay. All right. Let's see if we can do it by just looking at the answers now. All right, so here are the answers without the question.
Is it B?
Okay, how did you come up with B?
Because like it's like out of 10, and dish 1 is at 1 and dish 2 is at 2.
And you would be correct. So I didn't snip it in. You can see the words are missing. It tells you up at the top in the words that that it has 10 square meters or square centimeters. Isn't that amazing that you can answer this question without reading it, just looking at the graph and the answers?
Yeah.
And that's the kind of stuff that's going to set you apart from other people taking the test. It's not rocket science. It's about like being able to look and notice patterns.
Yeah.
All right. Now, again, like this doesn't always work. So like I'm giving you very specific problems. Your typical algebra problem, and I'm going to put the answers in front of you. When I say algebra, it's something you would solve, kind of like you were doing last part of your course. These are the answers. The only thing you can really sort of notice is that, okay, one of them's negative, there's a plus and a minus, the same number, but it doesn't tell you a ton.
Yeah.
So this doesn't always work. It doesn't always like be like, oh, I've got it. I'm gonna get a perfect score. Well, maybe. And you're always pairing it with another strategy. It's like you're never just like, oh, that works all the time. For example, this one, you can either try the answers and you have to decide if it's faster to try the answers or directly solve. So directly solve is what you've been doing in the classroom.
Yeah.
And I'll leave that decision up to you now. You don't need to show any work. You don't need to work anything out. You just have to get the right answer. So um, go ahead and give this one a try, please.
Okay. It's D, right?
You said letter B
D.
or D? D. D. Yes, it is D. Okay, very good. So the thing that I guess I realized I hadn't showed you is that almost all of these problems that we've been looking at today are called which of the following. So when you see a which of the following, you are forced to look at the answers. Okay.
Yeah.
And that's the whole point of this lesson is you have to know what the answers are. You have to know what the possibilities are. We talked at some point, and I don't know where this came from, but I was told you should always guess letter C. Okay. That is a terrible strategy in a which of the following. You would never actually guess C in a which of the following. You would actually guess D. Because more often than not, a which of the following wants you to go through all the possibilities is to take up time. Now, I'm not in favor of guessing, but if you were to guess, you would guess D
Okay.
because it's at the end. But that's only for this type of problem. Okay, let's look at another one here, and then we'll maybe switch to a content area here shortly.
Is it C?
It is C, yes. Oops. Sorry, I got the wrong color out. Yep, good. And again, there's really not much you can get from the answers. Like they're just numbers. Sometimes they help, sometimes they don't.
Yeah.
Okay, so to summarize that test taking strategy, some things in front of you here. This is typically how I structure the class. We spend about half the time talking about test taking strategy and then some more time on some other stuff. So a lot of questions are written in this form, which of the following? And when you get to college, same thing. A lot of questions are written this way, even in math. Which of the following? And that really requires you to do the following, which is to read the answers and compare them to one another. Works better with wordy answers where there's like an increase, a decrease, an up, down, left, right.
Mhm.
And then you can decide, well, what do I actually need to go back and like look for? I mean, we did a problem where you didn't even need to read it, but sometimes it tells you, okay, you better go back and find this thing. And that helps you to eliminate some answers or not. And we just mentioned this last point. When in doubt, guess letter C.
Okay.
All right. Any questions up before we move to solving systems of equations?
Mhm.
Quick review on that. Okay. All right. So we talked about, I remember we did this a little bit in one of the lessons, but we use the table method to solve systems of equations. And I want us to just quickly review the other two options. The first one is substitution. Okay. And you typically use substitution in one of two cases. So let me actually do it differently. Let me put this in front of you here. One of the variables is already solved for, or it is easy to solve for one of the variable. Okay. So I'll give you an example of that here. So in this problem that I put in front of you, the variable has already been solved for. Okay. Now we actually did this problem a while back using the table method. Do you remember us doing that?
Yeah.
Okay. Now they're giving you the values of y, and you can do it that way. Now for one problem here, I'm going to show you the substitution method, and then we can talk about how to do it with the table method. But just a reminder, you take this and put it in for y in the other equation. 2x plus 4 times x plus 2 equals 8. So the problem with this method is that it's slow, and
Yeah.
you may find that you don't actually solve for the variable you want. Like we don't really want x. And thankfully it's not there as an answer. If it was there as an answer, a lot of students would put that in. We have to go back and find why. I mean, it's not too bad to go back and say, okay, it's 0 plus 2. But the point is you want to not waste your time doing stuff like that. But we need to cover substitution, right? Now, elimination. You may get a problem where you have to use elimination. So both equations are already in standard form is the most common case. The variable coefficients in one system is a multiple of the same variable coefficient in the other. And that's very wordy, but let's see if we've got one here where these aren't that good. Okay, this is a better one. And you may have to use elimination or substitution when there are no multiple choice answers. That's why we're covering it real quick.
Okay.
So for example here, 1y minus 4y is a multiple of 1y. But 2 is not a multiple of 3. So you're sort of forced into eliminating y, which is good for this problem because when you eliminate y, you can find x. And you probably remember that you take the equation and multiply it by a coefficient to get the new equation. So it'd be 12x plus 4y. You're multiplying each of these by 12 equals 52. 2x minus 4y equals 18. And now you can add the equations together. So 14x equals 70, divide by 14, and x equals 5. All right, so I will put some problems in front of you, and I have no preference because I'm not grading you on how you do it. I'm just grading on you on the right answer. Substitution, elimination, or the table method.
Could we go
Do you
over the
want?
table method again?
Yeah. Let's do that with this problem here.
Okay. What?
So the table method only works for multiple choice. So as soon as the multiple choice goes away, you have to use a substitution elimination. The way it works is they give you one of the variables. They tell you this is y. And so you really want the x's. So you have to figure out a way to get the x's, and you can use one equation or the other. So I'm going to use the second equation just because I probably always do the first. So this is really 2x equals y, and x equals y divided by 2. And what it says is that the x value is half the y value, minus 3, minus 3 halves, 3 halves, and 3. And then what I like to do, because I don't like to read things backwards, is I'm going to rewrite the y values, and I'm going to just cross them out. And now you go to the other equation, y equals x plus 3, and hopefully one of these work. Now I probably avoid using the fractions, but you can see here x plus 3 minus 3 plus 3 is 0. 3 plus 3 is 6. There's your answer. So you create a table of x and y values to try.
Okay. Yeah.
Is that okay?
Yeah, that makes sense.
All right, let me see. Yeah, I don't think we did this one. So why don't you try the table method for this one?
Okay. I forgot like how to plug it in.
So if you're trying it in the second equation, you take the x value, put the x value in, minus 2 times the y value. So I'll just pick numbers that don't work, but it would be like 1 minus 2 times 1. Does that equal minus 3? And the answer is no, it does not. It's got to be from this list, but you're plugging those numbers in for x and y, multiplying by 2 and then subtracting. So this is 1 minus 2, which is -1. That is not -3. Does that help?
Yeah.
Okay.
Is it D?
Yes, yes, it is D. And you might consider sometimes working them backwards. Especially if you're
Okay.
trying the answers. I wish I knew that they would always work, but um, good job. Really good job on that. So um, any questions before we move on?
No.
Okay, so next question I'm gonna throw in front of you here. There's actually two ways to solve it, and it really comes down to like, which do you like better? Okay. Now,
Mhm.
you can always use one of the methods, elimination substitution. You can always make a table. Okay. One of the things that might cause you to not make a table is that you've got to solve one of these for y. But the second equation isn't too bad to solve for y. It's y equals minus 2x plus 4. But then you've got to put this value in to for every x value, you have to put into this equation and get a y value out. So that might be a reason not to do that. It's not like the last one where you could just say, okay, two numbers that add to 21. That's really nice.
Yeah.
You might also notice that if you add the equations together, if you add them together, well, y is eliminated. And one of the nice things about that is we're actually solving for x.
Yeah.
And so, okay, add them together, x is 0, and I'm done. Whereas if you make a table, right, you got to put -4 in there, -2 in there, 0 in there, and so on. And they got to try them in the other one.
Mm-hmm.
But it will always get you the right answer. Whereas if you forget how to solve, you're totally stuck.
Yeah.
All right.
All right.
So another type of problem you might see is one where the answers really don't lend themselves to the table method.
Mm-hmm.
Okay, because notice they're decimals, they're not whole numbers. It's not even that easy to solve for the other variable. Like even this is all the x values here. To get the y values, you got a real mess on your hands. You got to manipulate one of the equations or the other. So the table method is not an always works. Okay. In
Mm-hmm.
fact, this one needs to be solved by elimination
Okay.
as the fastest approach. So let's say we want to eliminate y. You've got -4y here and 6 here. It's not as if one multiplies into the other. You can't like go from -4 to 6 reasonably. But maybe there's a least common multiple that's not too bad. Like, is there a way, rather than multiplying by 6 and 4, is there another way to do it? Is there a smaller number that they both go to?
They both go to 12.
Yeah, exactly. So you can go 3 and 2. 24x minus 12y equals 21. Got to multiply all of them, all three of them. And then 6x plus 12y equals 24. And you add them together. So that's 30x equals 45. Good news is you're solving, you got rid of y. So when you solve this for x, you've got it. So 45 divided by 30, what does that become?
1.5.
It is 1.5. And this one is probably not a calculator problem, but really good. Okay, here's one for you to try. I'll leave the choice up to you. You can actually use a bunch of methods to solve this. It's a little bit harder than any of the ones we've done, but totally possible to use the table method, to use substitution, lots of options. So go ahead and take a look and let me know if you have any questions.
Can I do like elimination for this one and take out the 7x?
You can use elimination, yes. But it may not give you one of the possible answers because this is the first one's a quadratic and the second one's a line. And it's possible they're only giving you one of the solutions of X, not both of them.
Oh, okay.
So just be aware. You may or may not get exactly what you're thinking. But yeah, you could try it.
Is it D again?
Okay, could be. Let's what methods did you use? Did you use
I did the table method.
good. Yeah, I think that was the right approach here. It was kind of what I was hinting at. So the y value, y values are -14, -10, -4, and 0. Is that what you have in your table?
Yeah.
Okay. And like we talked about, you don't have to do them in order. Nobody's like looking over your shoulder to make sure you do A, B, C, D. Like I would look for the easier ones to try. So this last one is the best case. We know it worked there. So does it work in the other one? 7 + 3, 7 - 7. Why does this work in the first equation?
Because they cancel out to be 0 and 0 times anything is 0.
That's perfect. You could be teaching this. All right. So the other thing I'll just show you here real quick is that if you tried substitution or elimination. Okay, so first trying substitution. If you put, and I guess I don't know exactly how you tried it, but you could do it two ways. You could actually put this for y, or you could put this for y there. Either way, this is what happens. When you have x - 7 on the left equals x + 3, x - 7. If you divide them by x - 7, which you really shouldn't do, but that's what most students do, you get this right here, and that produces x equals -2, which is not an option.
Yeah.
But it is a solution. It's just, it's not the one they're looking for. You could also FOIL this out, and then, so if you FOIL it out here instead, and you get x - 7 equals x squared minus 4x minus 21, and then you move you subtract x and add 7, you get x squared minus 5x minus 14 equals 0. You then have to factor this. And that's the other way to do it. It's just
Okay.
not the same. And the reason is because it's not a linear system. It's not like the ones where you just put the numbers in and try them out here. So to be a little bit more creative, really well done. I put these in the challenge category because they're kind of the more difficult types of problems you will see. So well done on that. All right. We're gonna go ahead and stop here for